Video we will solve three more problems in the year 2007, 2008 and 2010. Let's start with the first question. In the year 2007, the first four terms of sequence are 18, 54, 162 and 486. Use all four terms to show that it's a geometric sequence. To show that whether the sequence is a geometric or arithmetic, you have to see the common difference or common ratio. In the case of geometric sequence, you need to show that all ratios are same. So here out of four terms, you will get three ratios. So first ratio is 54 over 18, which is 3. Second ratio is 162 over 54, which is also 3. And last ratio is 486 divided by 162, which is again 3. So in all three cases, your ratio is same. So you can say about R is equal to 3. It is a geometric sequence. B. Find an expression for the nth term of a geometric sequence. To find out the nth term of a geometric sequence, we should know u1, which is 18, and we should know r, which is what, 3. So first I will write down the nth term formula, u1 times r raised to n minus 1. So un is equal to u1 is 18 times r is 3 raised to n minus 1. Second part. If the nth term of a sequence is 1062882, find the value of n. Now this you can do by trial and error or using a logarithmic rule also. They have given that nth term, that means un is equal to 1062882. So substitute in this equation, 1062882 is equal to 18 times 3 raised to n minus 1. To isolate this term, first we need to get rid of this 18. It's a multiplication, so divide both sides by 18. So you will get 1062882 divided by 18 is equal to 3 raised to n minus 1. So you will get 3 raised to n minus 1 is equal to, you know the logarithmic rules. If I want to bring down the raised to power which is unknown, we have to use the logarithmic rule. So this becomes n minus 1 is equal to log of 59049 to the base of 3. This is basically I am using a formula of a raised to x is equal to b. So it becomes x is equal to log of b to the base of a. N minus 1 is equal to 10. So n is equal to 10 plus 1, which is 11. So your final answer is what, 11. Let's move on. Question number 5. Consider an infinite geometric sequence 3, 3 times 0.9, 3 times 0.9 square, 3 times 0.9 cube. Write down the 10th term of the sequence. Do not simplify your answer. If you'll see the trend, first term is 3, second term is 3 times 0.9 raised to 1, third term is 3 times 0.9 raised to 2, fourth term is 3 times 0.9 raised to 3. So your 1 mark answer is simple, u10, because they want 10 terms, so you have to write down u10. common factor is 3 as well as 0.9. If it is a fourth, raised to power is 3. If it is a third term, raised to power is 2. So if it is a 10, raised to power is 9. Please do not simplify this answer because they do not want. This is a 1 mark question. So you just need to write down the answer. Now find the sum of the infinite sequence. Simple. Again, S infinity is equal to U1 over 1 minus R. U1 is 3. The ratio in this case is 3 times 0.9 divided by 3, which is equal to 0.9, because 3 and 3 get cancelled. So 1 minus 0.9. So final answer is S infinity is equal to 3 over 1 minus 0.9 is 0.1. And 0.1 is basically 1 upon 10. Which is, again, if you don't know the rule, you can write like this. When you switch, they will flip because you are converting division into multiplication. So 1 upon 10 becomes 10 upon 1. So your final answer is S infinity is equal to 30. Now we will move on the last problem of this video. October-November 2010. First question. The first 3 terms of an infinite geometric sequence are 32, 16 and 8. Write down the value of R. R is equal to 16 over 32, or you can say 8 over 16. Cancelling common out, common factor is 1 over 2. Find U6. To find U6, I am writing UN formula. U1 times R raised to n minus 1. U6 is U1, which is 32, times R is 1 over 2 raised to 6 minus 1. Now this becomes 32 times 1 over 2 raised to 5. You are not allowed to use a calculator, so this becomes 32 times 1 over 2 raised to 5 is 1 raised to 5 over 2 raised to 5. You don't need to show this step, I am just explaining, that is why I am writing. So 32 times 1 raised to 5 is 1, 2 raised to 5 is 32. This will cancelled out, so your final answer is 1. Last part, find the sum to infinity of this sequence. Sum to infinity, use same formula, U1 over 1 minus R. U1 is 32. 1 minus R, R is 1 over 2. It's 32 divide 1 minus 1 by 2 is basically 1 by 2. So this becomes 32 divide 1 over 2. That becomes 32 times 2 over 1. So that becomes 64. So these are the problems we covered in today's video. Thank you.